To kickstart Chapter 2 for Advanced Differential Equations, which is actually the first order differential equations, let's talk about separation of variables, or the process of identifying whether the differential equation is separable or not. So let's talk about separable differential equations. This is very critical because the one of the simplest forms of solving differential equation is to identify whether the given differential equation is separable or not in terms of the variables. Because if we can come up with separable differential equation, we can simply use the basic integration of both sides in order for us to determine our solution. Let's talk about a certain equation in this manner. What if our equation express m of xy dy, let's say dx, plus n of xy dy is equal to 0. Say your m of xy and n of xy are two functions that are actually either has x or y or both. So it has, say for example, x plus y, x squared y, 2x minus 3y. These are examples of m of xy and n of xy. Say for example, our equation or differential equation is expressed in this manner. And if this could be transformed, this now we can say it's separable or not. If this can be transformed into another form, a of x only a function of x dx and a function of y dy still equal to 0, then we can say that our given equation is a separable differential equation. Separable in the sense that in our original given, our function of m and n are expressed in either combination of x and y or even just y and x alone. And if we could just simply manipulate that in such a way that what remains on the term with dx is a function of x, and for those in a function with dy, or our term with dy is a function of y, then we can say that it's separable. And if we can do that, right, if we can guarantee that it's separable, then we can just simply say this solution. The solution of separable differential equation is by integrating both sides. So by integrating a of x dx plus b of y dy is equal to the integral of the other side, which is 0. In that sense, you're just going to integrate a of x dx plus the integral of b of y dy. Of course, the integral is 0, is just actually NEC, right? So NEC is the integral of 0. So we can of course solve this further because this function only contains x and the notation here is for dx. And that's okay for the integral. Similar here, and for that, we can actually integrate that because it's only a function of y. So whatever would be the result of this in term of a function containing x and y, because this also has x, this also has y, so equal to your c, that is actually the solution of not just this separated function, but generally of the original given. So we will have examples as to this. We're to verify first whether the given differential equation is separable or not. And again, if it is separable, then we can use this process just by integrating both sides of the equation, and whatever will be the result, and that's already okay. Take note, for the idea of separable, make sure that what remains on the term with dx is a function of x, and for dy, function of y, so that we can actually integrate them. Thank you very much for watching.